A population is decreasing at a rate of 3.6% per year from an initial population of 9,000. How many years, rounded to the nearest tenth of a year, will it take the population to decrease to 1/3 of the initial amount? This is a decrease problem, so we're going to write down the formula for exponential decrease, which is y equals ae to the minus nt. The minus sign indicates decrease, increase would be no minus sign. Then we're going to identify each of the variables. Y is the final amount. A is the initial amount. N is either the growth rate or the decay rate, decrease rate. In this, it is a rate of decrease. So it's the decrease rate. And T is the number of years that this process continues for. So the final amount, it's not given explicitly. We're going to come back to that in a moment. The initial population is 9,000. Now they say the final amount is 1/3 of the initial amount. So 1/3 of 9,000 would be 3,000. N is the rate of decrease, which in this problem is 3.6%, which if we rewrite as a decimal is 0.036. And then T is what we'll be solving for. Let's now plug in what we know. The final amount, Y, is 3,000. A is 9,000. E to the minus N, which is 0.036, T. I want to get T by itself, so next up we'll divide both sides by 9,000. On the left-hand side we can reduce to 1/3. On the right, the 9,000s cancel out and we're left with e to the minus 0.036 t. Next up, I want to get rid of the exponential function, so we'll take the natural log of both sides. This way, on the right-hand side, the ln and the e cancel, and we're left with negative 0.036 t. And on the left, we have ln 1/3. Finally, to get t by itself, we'll divide both sides by negative 0.036. So this way on the right-hand side, these cancel out, and we're left with just t. And on the left, we can now evaluate this. ln of 1/3 divided by negative 0.036 gives us about 30.5 years.